Hey, so I wanted to try showing a really simple walkthrough, maybe about an hour long, about some like what I would consider the three fundamental things in programming that would apply to any language, almost anything you're trying to do in programming. So that if you've ever thought about trying to get started with it, that this might be a good place to get going. Um, I just wanted to preface this by saying that I did want to show something that you could use in your web browser to follow along with. I'm kind of highlighting it here. Unfortunately, for streaming this and recording it, I cannot get the software to hook up to my browser to show you this. So I'm using a different tool. But if you don't have, I'm using Visual Studio. If you don't have Visual Studio, odds are if you're watching this, you probably don't because you're not using it to program. There is this site called .NET Fiddle that you can type code right into. You can, if you want to follow along and do what I'm doing at the same time, you can absolutely use this website. It will actually put this exact same thing that you're seeing here to start, except my little comments up here. Um, so yeah, that's something you can use if you don't have Visual Studio. Otherwise, you can just watch and maybe absorb what I'm trying to say. But yeah, I think what I hear a lot of people saying is like, oh, it'd be really cool to program, but like I don't know math. And for me, I've been programming for a long time. Yes, there is some math in programming, but it's all about what you want to be programming. I have definitely written programs that have absolutely no math in them. I want to try to get to an example today that might have a little bit of math, and I'll show you why that's not even scary. But yeah, the three fundamental things that I think come up in programming are essentially keeping track of state. So as you're writing programs and things are, you have some flow and there's some progress in what you're doing, you need to be able to sometimes track how far along you are in your program or the status of certain things. So I'll show you the very basics of that. We're going to be using something called C# today. This should apply to essentially any programming language. So I'm going to try and explain it without the specifics of C#, and I'll try to call out like what you might see as differences in other languages. I'll talk about logical flow. So in programming, generally you'll run into situations where your program needs to make a decision about something. So that will be like, if some condition is met, we want to go do something. Otherwise, we might want to do something else. And that's what I'm calling logical flow or branch logic. And the final thing is loops. Um, and if you have never programmed before, this might sound like a weird thing, but basically being able to repeat something. You want to keep doing something while a certain condition is true. So, if I told you that we needed to count to 1 billion, you might want to write a program that can do that for you and loop 1 billion times so that you, as a human, don't have to count 1, 2, 3. So I actually try to get to an example that's similar to that today, but I want to kind of start in this order where we're going to try writing out some code where we can store some information into variables, and that's how we track state. Then we'll go into logical flow, and then we'll go into loops. And at the end, I'm going to try and piece it all together. So in about an hour, we'll try to get through all that. Okay, so the first thing I'll call out is that there's some stuff that's already on the screen here. I don't really want to focus on that for this. This is pretty specific to C#. So you'll see like class program, you'll see static void main with, it says string and args, and I don't want you to start looking at that and go, okay, like I already don't know what this means. Like it's too much, it's overwhelming. Where we're going to be putting code is right in here, in this spot. So we're going to be typing code into here. Try not to worry about everything else. The one thing that I'll get you to look at, though, is this console writeline. This is going to be something we can use just to make sure that we know what our program is doing. So I might refer to this console writeline, and this is just like when your program's running, you can see some stuff come up, and this is where we would print to the console. You can have some text come up, you can have numbers come up. It's just like if you want to know what's going on in your program, we can put information right into here, and that's going to show up. I really wanted to use .NET Fiddle to show you this because the console comes up right away. I don't think with my recording software right now, I have it set up to hook up to one window. When this console stuff comes up when it's running, I need to actually like switch windows. It's a pain in the butt. So I might not be able to show you that at the same time, which kind of sucks. But anyway, let's get started. And we'll get started, like I said, with keeping track of variables. Okay, so the first thing that we need to understand is that there's in a particular language, there's different types of variables that can store different kinds of information. So usually the types of things you're talking about are numbers. I'm writing comments out here, so that's why you have this funny green text and these characters. So there's numbers, there's words. Oops, I can't type properly. Words, and those are called strings in programming. So when I say the word string, I'm really just talking about words. And even a good example right here. Here is a string that says hello world. So if we wanted to be able to store words, we use something called a string. And then I mentioned numbers. And then in more complex scenarios, you have things like objects. So we're not going to talk about objects today. That's a little bit more advanced. And the other thing that is one of the most basic types is called a Boolean. So a Boolean is a yes, no, or true, false kind of variable. So it just says if something is on or off. Most simple type of variable. That's actually going to help us tie into our logical flow part in the next little section. But essentially, most programming languages, when it comes to variables, kind of to boil down to this type of thing. Okay, so I'm oversimplifying it for sure because I mentioned this objects one. That's a lot more complex depending on the programming language you're using and stuff. I'm going to go ahead and just remove that from our list so we don't have to think about it. Maybe we do another video on that later, but generally you're trying to look at numbers, words, and Booleans. Okay, so with that said, in C#, there's a few different types that you can use for numbers, and it's because there are different types of numbers to think about. That sounds kind of weird, right? So when we think about numbers, we're usually thinking about, if I want to count the numbers 1 to 10, like, there's 10 numbers there. There's 1, there's 2, there's 3, whatever, up to 10. Pretty simple. Okay, so 10 numbers from 1 to 10, but is that actually true? I know I didn't want to use math as a first example here because I don't want to scare people away from it, but there's actually many more numbers between 1 and 10, right? Like what about 1.1, right? What about 2.573? If you try to list out all the numbers between 1 and 10 that way, there's a lot more numbers. In some cases, you actually want to be talking about all of those other like decimal numbers that come between 1 and 10. In other cases, you don't. You just want to count 1 to 10. So we have different variable types that we can use to work with that kind of stuff. So if we wanted to do the numbers 1 to 10, we use something called, and not include the decimals, we can use something called an integer. Okay, so in C#, that's just called an int. It's just a short way to say integer. So an integer is a non-decimal number. Okay, so I can have an int, and the way we declare variables is we say, in C# at least, we would say the type. So in this case, we're talking about an integer, and we can give it a name. So we can call our first variable. Different programming languages allow you to type names in different ways. So there's different, what you might call like a standard for how to type things out, but we can call it like this. We can put underscores between things. We can have all lowercase. You're allowed to kind of do almost anything you want. There's some characters you can't put into here. Like I can't put an exclamation mark in the middle of this. You can see it's unhappy now. I got some red underlining. I got some green underlining. But there's some certain characters that different programming languages don't let you use. So no exclamation marks in our variable names. Yeah, there's lots of different ways that you can name things. Maybe just to keep it really simple and more readable, I'll put some underscores in between so that you can see the different kind of words that come up. So far, all I've done was I've put down a type, I've put down a name, and essentially this literally declared a variable for us to use. So we can write a program that, if we wanted, that can put information into this variable. Okay, so how we do that is that you need to be able to do something called assignment, right? So I want to assign some information into this variable, and that can hold the information for us. So if I were to put the name of this variable down, the way we assign things in C# is we use an equal sign, and we put a number, because we're talking about an integer, we put a number on the other side of the equal sign. Another thing just to call out in C#, these are all little language things, but in C# you have to end your line with a semicolon. Okay, so that's just a little thing in C#. You don't have to really worry about that. Maybe in a handful of other languages you use semicolons as well. If this is your first time looking at code, maybe typing a semicolon is probably the least common thing you do. I probably type more semicolons than the average person because I program in C# a lot. But what we've done here with these two lines of code, our very first two lines of code, is we've declared a variable that is an integer type. We gave it a name. That's all that this line does, is it lets us use a variable. We're not doing anything with it yet on this line. The second line says that we want to use our variable, and this is an assignment here, right? This is what the equal sign means, and we are assigning what's on the right-hand side, which is just the number 1. We're assigning that into our first variable. Cool. This is a program. It's not very useful, but it's a program. And if we ignore this console write line at the bottom, so ignore that for now, these two lines of code are a program that store the number 1 into a variable. Okay, that means we can also put the number 10 into that variable. We can put the number 5 into that variable. We can put the number minus 100 or 1,000 into that variable. These are integers. We're allowed to put the integer values of numbers into this variable. What we can't do is, I mentioned those decimal numbers, we can't put 1.2345 into that. See, it's complaining with the little red squiggle. And I don't think you can see when I hover over stuff. So Visual Studio has this cool feature that tells you why like certain things aren't working. But it's saying that this type of number cannot go into this on the left-hand side. So that means we can't put that in there. If we take the decimal out, we can, because this is an integer. But when you have decimal numbers, you can't do that. So let's see. There's another type of variable we could use if we want to store other types of numbers. There's actually a handful of different types. We're not going to do all of them. But in programming languages, when you're talking about decimal numbers, the most basic type of decimal numbers we talk about are called floating point. So in C#, float. These are little things that I'm not going to explain exactly why it's floating point. This is a type of decimal number that you can have. There's a double for double precision. There's lots of other stuff that's maybe more complicated and we need to worry about right now. But float variables let us hold decimals. So if we think back, how did we make our first variable? We had a type, right? And the first variable was int. For this one, it's called a float. And we can call this one our second. And just like that first line of code, all that this line here does is that it says to our program that we now have a variable that we can put information into. No information is inside this variable yet. So we can say our second variable, right? Our second variable equals 1.2345. Cool. Oh, it's complaining. This says I can't put this in here because it thinks that this right-hand side is a double precision floating point. It's too what's the word? It's too much resolution. It's too much information to put into here. So in C#, if you want to say that it's not, you put a little f on the end. Again, maybe more complicated than we need to worry about right now. But this lets us put this decimal number into this variable. So far, our program does two things. They're both not very useful in their current state, and that's okay. But we can put an integer number into the first variable, and we can put a decimal number into our second variable. It's important to note that in your code, when you're running your code, it will run from your top line to the bottom line. So these comments, these are comments in C# with these two slashes. These aren't lines of code that actually run. These are the lines of code that will run for us. So if we were to execute this program, what happens is that this code will get compiled for us. We don't have to worry about that. And there's going to be some output that the computer knows how to run for us. And it will run these lines in the order that you see. So it will do this line first, then this line, then this line, and then this line. And they happen pretty fast, which is why we're using programs to do things for us so that we don't have to do them ourselves. So those are two types of numbers we can store. What else? We said that we can store words. And we said words are called strings. So we can make a string called our third variable, right? And if we want to put a string, if we want to assign some words into this string, similar type of thing, we use our third variable. We use our assignment operator, which is the equal sign. And the way we declare strings is just like we saw, I was kind of hinting at it in this console Writeline thing down here. It says, hello world. That's a pretty common first program type of thing that gets used as hello world. So we can take a string, and that's denoted by quotes, right? In C#, you put double quotes around things to make a string. So this is technically a string. It's an empty string. There's no words inside of it. But I can put my name is Nick inside here, and now this is actually a string called my name is, or with the words my name is Nick, that get put into our third variable. So our third variable, once this line of code runs for us, will have the words my name is Nick into here. Pretty simple. All we're doing with these variables is assigning things to them. Right, so I'm keeping it very simple just to show you that there's different types. The last type that I want to talk about is a Boolean. And Booleans, or in C# we call them bool, again, some short form, they can hold true and false values for us. And these are really important types for us because when we're talking about logical flow of things, usually what we're trying to do is we say, if a condition is true or if a condition is false, go do something in particular for us. So that's going to be really important as we get into the next part. But true and false in Booleans really help our programs know if we need to go down a particular path, sort of like if you want to take the left path or you want to take the right path in a program. We write conditions that will check Booleans for us. So this is where I'm going to use a slightly more complex example in just a second. So we're going to call it our fourth. Oops. There we go. It's a lot harder to type when you're being recorded. So our fourth variable equals, and we're allowed to put true. If I could spell it properly, we can put the word true. And this isn't a word like a string is a word. This is a special keyword for us that really just means if the Boolean is set to one of its two states, so true or false, right? There's no quotes around here. This does not work, right? This doesn't work because I can't take a string I can't take a string and put it into a Boolean, but the word true, when it looks like this without the quotes, is a special keyword in C#. In other languages, it might look like true with a capital T. In C#, it's lowercase t. And that lets us store a true, or like the variable's turned on, it has a positive state. You can also put the word false into here. Okay, so these are opposites. True and false obviously are opposites. We can store only two things into a Boolean variable, true or false. Okay, so if we try to piece all of this together, something that we can do is, let's see, if we wanted to store in a variable whether the number 1 was equal to the number 2, we as people, if you know a little bit of math, you know the number 1 is not equal to the number 2, right? They're just different numbers. They're not equal. So we can write a really, really, really simple program that proves that for us. Okay, so I'm going to get rid of all this stuff we just typed, and we're going to write a little program that checks if the number 2 is equal to the number 1. So if we want to store two integers, we need two variables to do that for us. So int first number equals, and I said I want to check 1 and 2. You'll notice I'm declaring the variable now and assigning it all on the same line. Right? So I've already taken one step further. So before it used to look like this, right? We can take a little shortcut, make it a little bit cleaner, and put it all on one line. So first number, we're going to set it to be 1. Then we're going to do our second number, and we're going to make that equal to 2. Right? This is just like we did before, really simple. We're taking an integer number and assigning it using the equal sign to the first number. And then we do number 2, assigning it to the second number. Pretty easy. But we need to check if they're equal. And then we're going to take the output of that, because if something's equal, it's either equal or it's not equal. That sounds like a Boolean, right? So we want a bool, and we can call it is equal. Okay, so how do we check if two things are equal or not? In C#, we can check if two numbers are equal by using an equal sign, yes, but there's something special about the equal sign, because we already used an equal sign up here, right? We said equal sign is an assignment operator. So when you use a single equal sign, you're taking the thing on the right, right? The thing on the right, and you're assigning it to the thing on the left. Okay, so in C#, you still use an equal sign, but you're going to use two of them to check for equality. So we can say, again, so this is a single one, because we're going to take whatever's I'm about to type on the right-hand side, everything on the right, whatever that comes out to, we're going to assign it to the left-hand side. So we can say first number, and we use two equal signs. In C#, it's two equal signs to talk about equality. And there we go. So what this does, I'm going to highlight the right-hand side, is this is how in C# you would say, is your first number, and you're going to compare it. So C# uses two equal signs to do comparison. So is your first number equal to your second number? So if we were to run this program, first number is going to get assigned the number 1. Second number is going to get assigned the number 2. This just declares is equal so that we know that we can use it. Great. But that means first number has a number 1. This has a number 2. So really, it's kind of like saying this, right? 1 equals 2. And this is a question. Like, does 1 equal 2? And the answer to that is going to be no, it's false. So is equal will get assigned the value of false. So it evaluates the right-hand side for us, comes out to false, and stores that in is equal for us. I'm just putting those variables back. So what I'm going to do, just to prove this, is I'm going to put that into, this is a cheater thing for us. I don't want to get into method calls and other fancier things, but I mentioned console writeline lets us output information so that we can see it. I think it should come up in here. So I'm going to, if you're using .NET Fiddle, there is a play button that you can use to execute your code. I'm going to press this play button here. And I think it should show up in my output window. I know that what's going to happen, and for me, you won't see it in the streaming here, but there's another window that pops up, and you won't see it because I'm not recording it, and it doesn't show it here. Darn. Okay, this is where the output would go. So actually, maybe what I'll do, I think I can use this other thing called debug writeline. Again, I don't want you to worry about this. I just want to do this so that you can see the output come up. Cool. I think this should work. So I'm going to press play on our program again. And you can see, it might not be obvious because there's all this other noise in here, but it printed out false. And it's because false is what's inside of is equal here. So let's do this. I'm going to put one more thing. I'm going to use a string inside here, and I'm going to say the answer is, okay? So all I've done was I'm printing out some extra text before we print our answer, just so we can find it a little bit easier, okay? And you can see in the output, it says the answer is false. And the reason why is because 1 does not equal 2, and we stored that into is equal. And if you want to prove that to yourself, because you're like, you know what, maybe Nick's using something fancy and he's cheating and he's somehow printing out the number false and none of this code actually works, let's prove it. Does 2 equal 2? It should. So we should see the answer is, and on the next line it should say true. I'm going to press play. I'm going to check this little output for us, and it says the answer is true. Okay, so what we were able to do was assign a different value because 2 does equal 2. We put that into is equal, and then we can print that out. So this is a really, really simple example, and I think that might be good for variable storage and tracking state. It might not be obvious why we want that now because these are really simple examples, but we're going to go on to logical flow. And logical flow, I think, will be a little bit more interesting. Pardon me for showing, you know, how you can start to make programs that do maybe something a little bit more intelligent. Okay, so that's variables. Hopefully that was pretty simple. And what we're going to do is talk about logical flow. So logical flow, what do I mean by this? So we need something in a programming language for us that can essentially let us write code that says if we make, if one condition is true, do something for us. If another condition is true, do something else for us. So I wonder, yeah, maybe let's do this. I'm gonna put this example back. Actually, I'm gonna put this example back, and let's build on this. We might as well build on it because it's a pretty simple example. Hopefully, we understood what it's doing so far. Now let's actually change what it's doing. So maybe I don't want to just print true or false here. I want to print something cooler. Somehow cooler in this example, that doesn't really work, but I want to print something different than true and false. So we have a construct that we can use in C#. It's in basically any programming language, but how you write it in C# will look like this. It's called an if statement. And it literally means if, and then we give it a condition. So if this condition is true, let's run some code. Okay, so what that will look like in C# is we put the word if, we put some brackets, And this is just so that we can say if, and then we're saying everything inside these brackets. So if you could do is equal, right? Because what has to, when you're using an if statement, you're trying to check only if something is true or false. So if something is true or if something is false. So if something is true, and I'm going to put some curly braces here. This is a C# thing. This just means that if something, the way this reads is if something is true, we're going to go run the code we're going to put inside of these curly braces. You don't have to use curly braces if you only want to put one line in here. So if you wanted to run this line of code, good practice in C# is to put your curly braces in. That way, if we wanted to put multiple lines of code, you could do that. It will run all of these. Other programming languages, a good example is Python, don't need curly braces. So a lot of people like starting with Python because it lets you write code that looks like this. And everything that's indented, right, everything that has this spacing underneath this if statement will run. You don't have to put these ugly curly braces in. You just know that if your code is indented under your if statement, it will run. But we're not in Python, we're in C#, so we're putting curly braces in. So this is a really simple, and I mean, if statements are simple, right? So this is a really simple check that we've put in. It doesn't actually do anything for us, but we're able to check if this variable is true. Okay, so if this variable is true, we can run code. We don't have any code written in here, right? There's nothing is here. So if I were to run this, nothing actually happens. Let me see if I can. I'm going to pin this here so this will stay up. That way when I press play, you don't see me kind of jumping back and forth. But I'm going to press play. It shouldn't do anything different. It should still say the answer is and then print out true. Right? It still says the answer is true. So I put in this if statement. It literally doesn't do anything for us. But I want to do something. I want to do something cool. So let's put some other code inside here and prove that we can do that. So let's print out something different. I'm just taking this line. I'm copying and pasting it up here. And I'm going to put, this is so cool. It's not really that cool, but I mean, hey, we're programming. It's as cool as it gets. So I'm going to press play on this. And what this should mean is we said first number is 2, second number is 2. We're assigning, right, whether or not it's equal. 2 is equal here. Then I'm going to check. If it is equal, we're going to write this out. So let's see what it does. Right? This is so cool. Maybe you're not as excited as I am. But yeah, so we are able to check if is equal is true. And if it is true, we're going to write this out. I left in the other statements here, right? They still exist right up here. And this just proves to you the order that stuff is running in. And if we want to get really crazy, I can do. So what will this do? Any guesses? So we're talking about the order that stuff is running in. I'm saying essentially this reads, does 2 equal 2? Because that's what's up here. That should be true. And if it's true, we're going to write this out. And then right after that, I'm saying, you know what? Let's set that to false. So now it's not true. So we should see false here. But this should still get written out because at one point when this was checked, it is true. So let's prove that. Let's prove that. So press play, it's running. Right, so this is so cool because at this point in time, is equal was true. Then I set it to false. And then I wrote it out and it's still false. Okay, so let's fix up this example a little bit. I don't want to write true or false at the end. I want to write whether the numbers were equal or not. So let me make this look a little prettier for our example. So after when I say the answer is, I want to write out if they are equal. I want to put yes, they are equal. But what if they're not equal? Like I'm only checking if they are equal and writing this out. But what if they're not? So your if statements have this other thing that are called an else. So you can say if something is true, else, and else will mean essentially if this condition was not met, else go do this thing. So the else part is just the opposite. So this literally, if you think about taking a left path and a right path, is equal will take one of the paths and else will take the other path for us. So when we're talking about a Boolean, we only have two paths we can take. It's either true or false. So we can put out something else here. They are not equal. So instead of us writing in our previous example just true or false, we can make this code look way cooler to us, and we can have some fancy messages that we print out using these strings by using if statements to check if the numbers are equal. So when I write this out, what should happen? We have the number 2, so 2 should equal 2. That means is equal should be true. We're going to write this line out, which says the answer is. Then we're going to check our if statement. So is equal is true. We should see this one get put out. So let's find out. Press play. And we do get that. Yes, they are equal. Right? There's no more true and false being printed out because I got rid of that. We're writing out yes, they are equal. So that's awesome. But does the number 1 equal the number 2? Let's see if that goes into our else condition. And it does, right? It says, oh man, they are not equal. So it's because this part was false, so it's not going to go run it. Else, which means it has to be true. Let's go run this. Okay, awesome. Again, really simple examples, but let's move on from logical flow to the last part, the last topic, which is loops. So what we've been doing so far is really simple stuff where, you or I could probably look at the numbers we have here. We can probably tell if they're equal. We don't need a program to do that for us. It's nice that it could put that information out into a fancy console for us. That's cool. But we could do that ourselves. Computers are really good at doing that faster than us. So that's great. But they're also really good at doing repetitive work for us. And that's where loops come in. So a loop fundamentally just tells a program, like, I want you to keep doing this. Right? And that's really helpful because when you're trying to do more complex stuff or stuff that's redundant, you and I as humans, we're lazy. We don't want to keep doing stuff. Computer programs can do that for us. So we can use loops to do repeated work for us. So let's get rid of maybe this program. I don't think I need to build on this example anymore. So maybe, oops, I'm going to copy and paste a line. So I'm going to steal this one. So let's see. Let's talk about what loops can do. So I have this line that says woo. So if I were to run this program, the only thing we would see is woo come out. So what if I wanted to print that line many times? One way to do that is I can say, right, if I were to run this, and I'm going to, it's going to print woo out many times, right? And put it a whole bunch of times down here at the bottom. So that's not too exciting, but that's what it does. But if you kept doing this and said, okay, well, that's nice that you wrote it out like whatever that is, like 10 times or whatever. What if I said I want you to do it 100 times? I mean, one option is that you take this and you go, okay, well, if that was 10 times, I didn't actually count it, maybe it's not 10, but you could do this. But now you have a really ugly program, right? I can keep putting in these write lines that print out woo. And then I said, okay, well, instead of 100 times, like I want you to make it 76 times. And you go, oh crap, like, if I had 100 lines here, I need 76. I got to take out 24 of these, okay? And like, it's not really. You don't want to write code that you have to copy and paste code like that. It's really hard to maintain. There's better ways that we can do that. So we can use a loop, right? Because we're doing the same thing over and over again. So we might as well tell the program, just loop through this for us. So there's different types of loops, and they show up in different programming languages, but the way that you write them out looks a little bit different. So I'm going to take a particular type of loop we're going to talk about just because it's easy to write out. It's intuitively, I don't know, there's other loops that are better suited for counting things, which is really what I want to do. But the syntax for them looks kind of gross, and I don't really want to show that if you've never seen a loop before. So a really simple loop that we can do is it kind of looks like an if statement, but instead of using the word if, we're going to use the word while. Okay, so while is a special word in C# that basically says while this condition that we're about to put, just like an if statement, right? While this is true, do stuff. So essentially, while this condition that's inside these two parentheses is true, we're going to do stuff. So an if statement used to look like this, right? So if this condition was true, we would do this once. But if we put while here instead, and we say while this is true, it will keep doing stuff. So that sounds pretty neat. What's going to happen? So if I say while true, I'm going to put debug writeline with woo in there. What should happen? Are we going to see it once? No times? 2 times? Let's find out. So we see it a lot more than 1 or 2 times. In fact, it just keeps doing it. You might not be able to tell. I'm trying to scroll up to keep reading through the woos, but they just keep coming, right? And that's because our program loops for forever. This is a loop that will loop for forever. And the reason why is because it says while this condition is true, keep going. But the reality is the value true is always true. True is always true, so this will go for forever. And it's still going, right? It's not going to stop unless I tell the program to stop running. So that's called an infinite loop, right? It's going to keep going because true is always true. And just to prove this, I'm going to clear this out for us so we don't have to look at that. Well, what if I put false here? How many times is that going to write out the word woo? Let's find out. Well, it didn't come out at all. And why? Well, false is never true, right? So this says while this condition is true, but false is never true. So while it's true, go do this stuff. So because it's never true, it's never going to go run this code. Okay. So that's a pretty useless example, but I'm just trying to illustrate that if it said while something is always true, it'll go for forever. And while something that's never true is true, it'll never do it. So those are opposites. Well, what about something in the middle? So what we can do is try to combine in some of the last information we worked with variables, and we can combine that with our while loop. So if I said I want to print out this line 5 times, how do we do that? Okay, so if we want to print something out 5 times, well, if we do it once, maybe we could track that we did it once. And if we did it twice, we could track that we did it twice. And maybe we could loop until we've counted like 5 times, right? So that's how, if you were being asked this, that's kind of like the thought process that you want to put into this, is instead of trying to copy and paste this X number of times, you could say, well, if I need to do it a certain number of times, why don't I count how many times I'm doing it and just stop when I'm done? Okay, so let's look at that. If I had an int and I did int count, and I'm going to start it off at 0 because we haven't counted anything, we can change the condition inside this while loop. We change the condition inside this while loop to only count a certain number of times for us. So we say while count, and we're going to use a different type of check. So before we had 5, or sorry, oops, before we had 2 equal signs to check if something was equal. Well, I don't want to check if it's equal. I want to say while it's less than 5. Or I want to say while it's less than or equal to 5. I want to do this. Okay, so did this work? If I go run this, is it going to print it out 5 times now? Let's find out. So I'll hit the play button. Uh-oh. Nope, that didn't work, did it? But why didn't it work? It's still printing. It's printing out for forever again. It's infinitely looping. So what did I write, though? I said, let's make a variable, right? We have an integer variable. We're putting 0 into it. And I'm saying while this is 0, while 0 is less than or equal to 5. Oh, wait. 0 is always less than or equal to 5. It's always less than 5, right? So that's always going to keep looping. So, okay, I called a variable count, but I'm not actually counting anything, right? So how do I count? Well, to count would be 1 more than the last time. So why don't I take our integer and make it equal to itself, but 1 more? Right? So this is how you can count, right? So I'm able to take the same number. So to start, the very first time, it is 0. And then I'm going to make itself equal to 0 plus 1. Then the next time it comes through this loop, right, because it goes back to the top of the loop and says, oh, you're still less than or equal to 5. Okay, well, now we're going to assign 1 plus 1. And the next time through, it's going to be 2 plus 1, and then 3 plus 1. So this lets us add 1 to our count each time. So if I press play on this, what should happen? Let's see. 1, 2, 3, 4, 5, 6. Oh no, I can't count properly, can I? So how do we make this better? I thought I was counting up to 5, right? I was checking that here. But the first time through, it's 0. Right? The first time through, it's 0, and we print it. And then it goes to 1, and then it goes to 2. So if I write it out, the first time through, it's 0, then it's 1, then it's 2, then it's 3, then it's 4, then it's 5. How many numbers is that, though? How many numbers is that? I mean, 5 is the top number, but I wrote out 1 number, 2 numbers, 3 numbers, 4 numbers, 5 numbers, 6 numbers. That's why we see woo printed out 6 times. Cool. Okay, so there's a couple things we can do to fix this. We only want it to go 5 times. It looks like we're counting up to 5, but we either need to start at 1, right? Because then we're not going to have this number anymore. We'll start at 1. That's 5 numbers now. 1, 2, 3, 4, 5. We can do that. Or we start counting at 0. And in programming, in almost every language, you usually you count from 0. It's just a common thing. It's not common for most people, but for people programming, you count from 0. So if we want to count from 0, instead of counting from 1, we can take this equal sign off. And what that will mean is that we have to count while we are less than 5. So it takes this number off. And how many numbers is that? 1 number, 2, 3, 4, 5. So let's run this again and see if that works. 1, 2, 3, 4, 5. Cool. So that printed that out for us. Awesome. And if we wanted to prove it to ourselves, you saw me manually count out how many times you saw woo. Well, what if I said I want to prove that we can write this out 10,000 or sorry, 12,743 times? Well, that would suck, right? I'm not going to count that many woos. So what if I just said, okay, well, why don't I print out the count? Right? I want to prove that this loop actually goes that many times. Well, let's run it and see. And if you're watching down here, you can see that it's counting up and up. And it's going to keep going. Probably should not have picked a number so high. Basically, just something interesting to call out is the computer is very able to count to 12,743 significantly faster than what you're seeing here. The reason this is actually counting very slow, extremely slow. And the reason it's so slow is because it's actually it's printing this information to the console. That's actually slowing it down for us. Because we're still not at 12,000. I mean, it's counting faster than probably you or I could, but this is very slow for a computer. So I don't know how long that took, but it should stop in just a moment here. Boom. So it ended at 42, right? But that's because we started at 0, right? So it should be 12,743. Okay, so interesting. That took a long time. Well, what if we just did this then? And I want to prove to you that this is going to make it really fast. So this line is really slow code to run. If we're just interested in seeing the final number, let's see. I think this should go a little bit faster. Oh, it's already done. Right? It's already done. And it counted up to 12,743. So that's a good example of why you might want a computer to do something for you, right? We don't want to count up that high ourselves. That sucks. But let's build on this example. I said I wanted to take about an hour to do this video, so I got about 7 minutes left. I think we can probably nail this in about 7 minutes. So the thing that I want us to make is I want to count the number of even numbers and the number of odd numbers up to a certain number. So if I said let's go from 1 to 10 and count the number of even numbers and odd numbers, you or I could probably do that pretty fast ourselves, but let's write a program that can do that. And why? Because I'm going to change that number from 10 to something really crazy. And once we have our program, we should be ready to go and be able to change that number to whatever we want. Cool. So let's combine everything we learned in the last, 50-ish minutes to make that happen. So I said I want to go from 1 to 10. I'm going to write it out from 1 to 10, all, so count just to make it simple. I want to count the even numbers and I want to count the odd numbers. So if I read what we're asking to do here from 1 to 10, that kind of sounds like a loop, right? Because in our previous thing, we said we were going to loop up to 12,743. So maybe we're going to go from 1 to 10, right? From 1 to 10. And that's not true. This says 1 to 10. So I want to include 1 and I want to include 10. You see the little change I made there? Instead of going from 0 up to less than 10, I'm going from 1 to less than or equal to 10. So this makes us go from 1 to 10. Cool. And I want to count the even numbers and count the odd numbers. But I want to count them separately. Okay. So, I mean, let's figure that out. So I want int even. So I have 0 even numbers to start, and I want to track the number of odd numbers. So even count and odd count. And maybe just to make this a little bit more obvious, I'm going to call this loop count. Okay, because we got lots of counts now. We got 3 counts. So I actually want us to call that loop count, just so we know that we're talking. That's the number of times it's looping. Okay, so I want to count the even numbers and odd numbers. So I mentioned at the very beginning of this, I'm going to throw in some math. People are always afraid of math. And I'm going to say, well, some really simple math is like, if I want to know if a number is even, that means 2 has got to be able to go into it, right? It has to be divisible by 2. And people might have heard the word divisible and they're already getting scared. That's okay. No one likes thinking about math. But to be an even number, it has to be divisible by 2. So if this is a thing that people don't realize about programming, if I asked you to do this and you're like, listen, like, I don't know how to check if something's divisible by 2. You know, like I know in C# how to do that. I probably have a good guess in other languages, but if I didn't, literally, I would go onto Google and I would type, how do I check if a number is divisible by 2 in the programming language? I would literally type that, and you're going to get given an answer. So if I were to type that right now, the answer it's going to say is you want to use something called a modulo, or the Modulus Operator. So that sounds pretty terrifying already, but it's actually pretty simple. And all that does is it gives us the remainder when we try to do division. So again, I'm throwing a bunch of math out. Hopefully it's not scaring you too much, but the idea is that if a number is divisible by 2, we can use the modulo operator to check if the remainder is 0. There should be no remainder when a number is divisible by 2. So that's a really important piece of information. So I'm going to write it down. Modulo operator can be used. So if no remainder, if there's no remainder when modulo by 2, then it's even. Okay, so that's an important piece of information. Let's try using it. So what does that look like? Well, we can check. I said if, I literally wrote it, right? If there's no remainder, when we do a modulo by 2, then it's even. Okay, so if, right, we can use an if statement. So what does a modulo operator look like? Well, and we can use our loop count too, right? Because that's going from the numbers 1 to 10. So if loop count, the modulo operator is a % in C#. So if we were to do loop count modulo 2, and we say, is that equal to 0? Right? So we're checking the left-hand side and the right-hand side. Remember, double equals is a comparison. A single equals is an assignment. And it doesn't like that, so we got to put 2. We're checking if 2 things are equal. So if loop count modulo 2 is 0, this is even. Okay, and if it's not even, it's got to be odd, right? Okay, so even and odd, we have an if and an else. And this was the secret. This is not what, if you've never programmed before, I wouldn't expect you to know this modulo operator. And I wanted to be able to show you that, maybe math is scary. No one likes doing math. I get it. I hate doing math. But you can Google it really quick. You can check the language you're trying to use, and it would tell you can use a modulo operator. Cool. And if it's even, I'm going to make the even count equal to the even count plus 1. Right? So I'm going up by 1. And if it's odd, right? Because if it's not even, it's going to be odd, and we increment the odd count. Okay. And then we have our while loop. So we want to print that information out at the end. I'm going to do it like this. So even count, I'm going to put odd count. And then in the middle, I'm going to print the even. And at the end, I'm going to print the odd count. Cool. So from 1 to 10, how many even numbers do we got? And how many odd numbers do we got? Let's find out with our new fancy program. 5 and 5. That makes sense, right? That makes sense because the number of even numbers is 2, 4, oops, that's a 3, 2, 4, 6, 8, and 10. So 1, 2, 3, 4, 5. And the number of odd numbers is 1, 3, 5, 7, 9. So 1, 2, 3, 4, 5. So 5 and 5. Okay. And just to prove it, it's not some sort of sorcery. If I put a 9 here, that means we'll never get this 10. Right? So how many even and how many odd numbers should there be? Let's run it, find out. Uh-oh. What's wrong here? What's wrong here? Even count is 5. Even count is 5. Right? That's not right. So I just put a breakpoint in here. We can actually see what's going on and walk through it and find out what's going on. So let me start it again. I didn't mean to do that. Okay, so I wanted to put both breakpoints so we can step through and see what's wrong with our program. I said if we're going from 1 to 9, the even numbers we should see are 2, 4, 6, and 8. That's only 4 of them. And odd numbers 1, 3, 5, 7, 9. That's 5 of them. So why do we get those backwards? What's wrong here? So these breakpoints stop our program when we're running it. We can actually see what's happening in here. So even count and odd count. So even count starts at 0. Loop count is 2. Interesting. So I wonder what's going on here. This is the first time we're going through our loop. And loop count is already 2. How did that happen? How did that happen? Well, let's stop that. So something's already not right. Something's already not right. So why is that happening? I'm going to put a breakpoint right at the top. So we're starting off, loop count is 1, right? That's exactly what we said. We want to start at 1. So loop count is 1. I'm going to go through line by line of code because we need to go from 1 to 9. Oh, wait. I have loop count plus is 1 at the top. So loop count is already 2. Maybe that's why. Right? So the very first time we're going through this loop, I said I wanted to start at 1, but the first thing we do inside the loop is that we go from 1 to 2. So how do we fix that? How do we fix that? Well, what if we made this happen at the end of the loop? Right? What happens then? Let's find out. That's better, right? 1, 2, 3, 4 even numbers. That's what we see here. 1, 2, 3, 4, 5 odd numbers. That's what we see here. So that seems to be a little bit better. And the reason why having a program to do this for us is nice is because if I said how many even and odd numbers between 1 and 12,743, do you know the answer off the top of your head? Because if you don't, if you had a program like this, you could have the answer by pressing a button and having it right there for you. Right? So a really simple example, we're just counting even and odd numbers. One of the most popular programming questions that can get asked in like a job interview, if you just want to test some basic programming knowledge, it's something like this actually. And the reason why this is a valuable test of someone's basic programming knowledge is that you have to use variables, you have to use loops, and you have to do some conditional checks, right? This branch logic. So that was a really simple way for us to combine all three of those things where we're using variables, we're using loops, and we're using if statements. Those are the three sort of fundamental things I said come up in all programming languages. You can build on top of those, start making more complex things. We already have variables being assigned to themselves, but incremented. You could assign variables to other variables. There's different types of loops you could look at. There's other fancier math that's not just modulo. There's lots of things you can do. But this is just really basic ways to explain like how you can flow through a program. And hopefully that made sense. I know I didn't explain how what's debug Writeline actually doing. That's a conversation for another day. I just wanted to be able to let us use a bit of a cheat code here so we can see stuff getting printed out. If you were using .NET Fiddle, or if that's something you want to go try out now, you can totally use console Writeline in .NET Fiddle. It will print out. This is called a console. It will print out the same way if you use console Writeline. So that's something you can try out. But yeah, that's hopefully a really simple how-to for getting started with coding. You can hopefully apply these concepts to any programming language you want. So if you're like, Nick, C# sucks, I hate it, it's ugly, I hate these curly braces, and I hate these semicolons, that's cool, I get it. You don't have to use C#. You can go try this in Python, right? Maybe that's a good thing to try. It's like maybe you try it in .NET Fiddle, and then you go try this in Python, and you see what the differences are. You'll notice it looks very similar. It should look very similar, but there will be subtle differences. And if you start to learn one programming language, you can actually take a lot of these concepts like variables, loops, and if statements. You can take those concepts and apply them to other programming languages. So hopefully that was helpful. Hopefully not too boring, and hopefully you learned something. So thanks.